Okay, it's time for a quick test. So I'm going to start sharing my screen here. It's on slido.com. You know how this works. Open your browser and go into slido.com. And the code is 81713. It's 6 questions. And a lot of them, it's the same question I asked in the previous tests. So just checking that, some of the concepts we discuss here are sticking on your brain, and that you're getting a grasp of how Revit works. That's all the purpose, nothing to sweat about. Although, if somebody get it all correct, I might give a prize. I don't know. A virtual prize, a virtual hug. All right, Cecilia, B, Steve. Again, you can also do it on your iPad or your phone if it's easier. I'm also going to post this link in the chat panel. All right. I have 6 people. Jennifer is here. Hey, Jennifer. I think you're muted, Jennifer. I just want to double check, Jennifer, that one of your coworkers is joining this call. Is that correct? I was told that one of your coworkers will be signing up for this class. Gretchen. I sent her all the information. So you're muted, by the way. Okay, I have 8 people on the call here. Let's get started. All right, based on the information on the screen, what is the type name? Remember, there were when we pre-highlight something, Revit give me information on different tiers. But this might be a little tricky because there's an extra level of information, and I'll clarify that later. But the structure, if you go from the higher hierarchy to the lower hierarchy, it's a consistent set of element tiers. All right, I have 6 responses. Let's see what the answer is. Okay. Majority got it right. The SG metal panels roof is the type name.
Oh, the type name.
Yes.
Messed up.
Now remember that, the first piece is the category. This is the category.
Yeah.
The name of the family.
Okay.
And this is the type. Now, R1 is a subtype, and subcategories have subtypes. Not all categories have subtypes, and those are built in coded into the family type. But if we look at the sequence, it will be category, family, type, and subtype. It's a good job to everyone. Let's see the next one. Oh, now we have a leaderboard. And this is how soon you're able to respond to the question.
Oh,
And Ahmed, it's taking the first place. Okay. Again, I put these questions in the previous test. A collection of elements with the same properties, behaviors, and physical representation is it a category? Is that the definition of a family, or is that a definition of a type? Let's see, 2 responses. And remember, the key is in this word, a collection of elements.
could be.
I see all responses. Let's see the answer. Yes, family. Family, it's a collection of elements with the same property, behavior, and physical representation. Category, it's a very similar definition, but it's just elements with similar properties. But that doesn't mean they're going to be represented exactly the same way. Because column, there are round columns and there are rectangular columns, and they're steel-shaped columns, and they all have different physical representation, but they're still part of the category. But when they have the same physical representation, they are called a family. Good job. Next one. Well, good job, Cecilia. That was fast. That's like less than a second. All right, this is also in the previous quiz. Walls, roofs, ceiling, floors are examples of a component family, a system family, view-specific families, loadable family. There are families that can be saved as an RFI, and there are families that cannot be saved as an RFI. All right, all answers in. Let's see what's the right answer. System families, that's correct. System families are families that can only be created inside a Revit project. You cannot save them as a component. Loadable families and component families are exactly the same thing. You load them from an external repository of files, but wall, ceiling, roof, and floors, you cannot save them as a file. Those are system families. And one particular property of system families is that they are created using boundaries, and those boundaries are called sketch lines. And remember, the rules of sketch line is that sketch lines need to be closed in a closed loop, and they cannot overlap. And anything that uses a sketch line, it's a system family. All right, let's see next one. Good job, Amit.
Thanks.
Easy. What is the shortcut for visibility graphics overrides? VB, VS, or VB? Or in? All right, let's see. V, that's correct. This brings the visibility graphics override dialog box, and this is used to control the object display and the graphic controls inside a particular view. VS and BV doesn't do anything. All right. Again, Ahmed and V and Louisa. All right. I think I did not. I mentioned this in the past, but see if you can get it right. I might not have explained a lot of the different type of parameters, but a parameter that is unique to an object, is it a family parameter, a type parameter, or an instance parameter? All right, all in, let's see. That's correct, instance parameter. Let me show this slide because I don't think I showed a bit before. But when you select an object in Revit, all the properties that appear in the property window are called instance properties. And those are properties that are unique to an object. And then in the instance property, there's this little button that's called the edit type. When you click that button, it opens the type properties. And it's this other dialog box. When you change, these are properties that are common to all the elements of the same type. If you change a parameter in the type properties, it changes it for all the instances in the project of the same type. And so an example of this is in the case of a window, is the window size. This is a single type. If I change the width and the height, it's going to change the width and the height of everything that is part of that. And that's why it's very important to duplicate, rename, and change parameter values when we're creating a new family type from an existing one. So instance properties, anything visible in the property windows. Type properties, anything that is inside the edit type button, that its properties common across the site. All right, let's see. B, good job. And I think the last one. What is the name of this set of tools? All of them, not just this one, it's all of them. It's part of the user interface. All these tools have a name. All right, let's see. View controls, that is correct. The view controls are tools that manipulate the graphic properties of the view. So here you can change how things appear in the view. You can change the graphic controls, the detail level, the illuminance, the sun properties, turn things on and off, etc. So good job, everybody. All right, so B, you get the first place for responder faster than the rest. You're good. You're good. Second place, Luis.
That was all luck.
Let's see what happens next Thursday. Let's see if we remain invict. Okay. Let's close this thing and let's move this to my other screen here. And let's pick it up from where we left it. All right, so last class, we created structural elements. We created our first system family, the floors. And I'll show you that the system families are always created using a set of purple boundaries that are called sketch lines. When you edit the boundary, you have access to those sketch lines, and then you can modify them. You don't have to do this. But this is a way in which you can edit a floor. You can just edit the sketch lines, and then the boundaries of that system family will be changed. We also look at how we created levels and grids. We created our first columns. We create columns in bulk rather than doing them one by one. We loaded components from a library of components. And then I show you how to extend the underside of the columns to the underside of the slab. And this was an offset property that it's available to you in the instance properties of the column. We reduce them all by 6 inches. Then we created a new family based on an existing one. This is important. So you don't have to do this. I'm going to repeat the process. To create a new type based on an existing one, you edit the type, you duplicate it. Say I'm going to create a generic floor that is 8 inches. That's step number 1. Step number 2 is to give it a name, which I'm just doing. And then step number 3 is to edit the internal properties. And then I create a new floor, generic 8 inches with different properties, but it's a new type. So I'm not affecting the types existing in the project. What you don't, I don't do this, but what you don't want to do is to go into the edit type and don't duplicate it, because if you change the properties of this floor, you are actually changing for everything that is in the model. Remember, changing a type property changes the properties for all the elements of that type. And therefore, you could be inadvertently changing everything in the project. Revit is not going to warn you. It's not going to tell you that 500 doors are going to be changed. It's just do it for you. So we created a new type. There is a property I forgot to mention. And when we have conditions like this, where the column is intersecting a sloping surface, you could use a contextual command called attach top of a column. So when you select this column, for example, and I wanted to neatly expand to the underside of this slab, then you use this attach top base and then select the floor. And what Revit's going to do is just to extend the underside to the extend the column to the underside of that. It doesn't do very neatly. That I don't like that, but it will do at the lowest point. Another thing you could do also, I'm going to do this here. It's we can reduce the height of these. Let's say I'm gonna give it a top offset of minus 9 inches. Actually, minus 10. Let's do minus 10. No, not 10 feet. 10 inches. That's 10 inches. And then you can do something that is cut geometry, which is under the modify tab. And then you find this cut tool. So cut is going to cut geometry based on another one. Give me a second, I need to. You know, I'm teaching right now online, and I need to get out. Okay. All right. Salespeople. It's rare to find salespeople nowadays. Anyway, we could use the cut command to cut a geometry with another one. So you hit cut, and then one thing you could do to understand what's next is to pay attention to the instructions right below. Like when you're in the middle of a sequence and you don't know what's happening, Revit tells you what is expecting you to do. So if it tells you there what is an element to be cut, I want to cut this with this. Sorry, cut this with this. It's not working. Okay, never mind. I think it only works with elements of the same category. Cut this with this. Not working. I think if this was like 2 floors, it would work, but it's not working. Anyway, but this is an intersecting element. Let's see if it join it. Join this and this. Oh, when I join it, it does. You look at it. It cut very neatly the top of the column to the underside of the slab. And I think you could do the same in the opposite end. Again, you select this, and I'm going to do an offset of -10 inches, and do the join. Join this with this, and it's literally a cut. All right. Now let's build the upper levels as a wood structure, and we're gonna switch to a floor plan. So in the project browser, go to level 2, and notice how on level 2, I still have a display of the columns underneath. And if you notice closely, they are in gray. So what's happening is that levels have by default something called an underlay. And underlaying is a property of the view. You will find it in the properties, in the property panel of the floor plan. And if you look at these parameters, there's something called a base level and a top level. And so what this is telling you is that you will have like a sketch, like a paper sketch right underneath your view that's going to start from level 1 to level 2. And everything that is visible between level 1 and level 2 will be visible as a grayscale. And so the underlay orientation, it says looking down. For the most part, you're going to look down. But when you're doing, for example, reflective ceiling plans, you're actually looking up. But you can be looking at a ceiling plan and look down in case you want to like organize things like the furniture and align the furniture below with the ceiling plan above. So that's an example where you will do look down, but the view will be looking up. So you don't have to do this, but if I change this to none, notice how the columns disappear. I'm no longer seeing those elements underneath. And so these kind of things are useful if you want to coordinate things like the restrooms are on top of another one, or that the corridors in the upper floors are exactly in the same location as the corridors below. Or if you want to look at the projection of the roof in the ground level, there's something that landscape architects care about, then you can place your roof level as an underlay and then the roof layer is going to appear in the background. We don't have a roof level right now, so that's not going to work. But I'm going to leave this as level 1 to level 2. This is the range in the view that's going to be visible underneath my active view. Now, the other thing you're going to notice is that these columns, I cannot select them. Now, there is a property, there's a selection control that I didn't talk about it in the past that enable me to select elements in the underlay. And that is this little thing here. I don't know if you notice it. It's an icon that looks like 2 layers on top of each other. And these activate or disactivate the user ability to select objects in an underlay. So for example, if you're coordinating upper floors and you realize that the lower level needs to be changed, you can enable your ability to select objects underneath. And now you can select the column. And so you can be working in level 3, level 4, level 5. And if you select an appropriate underlay, you can manipulate those objects. Now, most of the time, those are just for reference. So I will recommend that you disable this and keep it disabled. So these are the selection control, if you remember the name. And these, I think we look at a couple of them. These enable or disable the user ability to select pin objects. Remember, if I select a grid and then I pin it, and I disable the ability to select pin objects, then this grid is a reference. You cannot select it, you cannot move it. And maybe that's a good thing. Maybe pin objects are there so that you don't select them and you don't have to move them. The other one is the ability to select elements by face. So here I click in the middle of the floor and I select it. And then if I click this again, I cannot select element by face. For the most part, keep it on, disable it. So meaning that red X. The red X means it's disabled. Then this is to enable and disable the selection of links. I don't have a link here, but if I have a structural model, I want to make sure that it's only shown as a reference and that a user doesn't move it by mistake. And then this one is a little less obvious. It's this little arrow, that little plus. And these enable or disable the user ability to move something by click and drag. I don't like that setting, and maybe I shouldn't teach you. So if you notice, when I click and drag, just by clicking and dragging, you modify the location of an object. Click and drag moves an object. But if I disable that, then that behavior, what is it? Yeah, that behavior doesn't happen. So again, if I enable it, I hover over, I pre-highlight, click and drag. That is dangerous. I don't like that behavior. But then if you disable it, and I select an object or pre-highlight an object, it doesn't do that anymore. And so for the most part, I would say disable everything except, disable everything. Disable everything by default. And you're gonna make sure that things that are pinned don't move, links don't move, objects don't move by mistake, and then you don't select object by face. So the same properties that you see here are the same properties that you will see in this drop-down list. So these checkboxes right underneath the Modify tab are exactly the same as these 5 elements. So select links, underlay elements, pin objects, element by face, 2 different locations to do the same thing. If it's clear, that means it's disabled. If you check it, then that means enable. This other one, this icon over here, it's for background processes. And this, if we use cloud processes, for example, if I was running a cloud rendering, or if I was synchronizing with Central in the cloud environment, it will tell me how much time is left for the procedure to finish. And then the last one is the filter, which we cover in a previous class. All right. A question here? All right, we're going to use the same grids to place a wood structure. And the wood structure, then we're going to create a system of beams. And then we're going to create some joists and a wood floor. So let's create columns. So you use the architectural tab, then hit the column tool, and in the property window, click the drop-down list, and you should have a 6x6 model, timber column, 6x6. And if I don't want to create them all one by one, I can create them in a single step. We look at this last class. Now, the next thing I'm going to do is look at the method of creating those. We want to create them by height. We don't want to create them by depth, because by depth means it's going to start from the current view and it's going to go down instead of up. So I'm going to change this to height, and it's going to start from the current level all the way to level 3, and that it's a reporting height of 9 feet. And we're going to do all of them at grids. And I'm going to create a crossing selection from the lower right to the upper left to create a column in every grid intersection. Revit will give you a preview. You can see that. And then hit the green checkbox, finish. And then to cancel the command, escape. All right, this is, if I switch to 3D view, these are the columns created. There are some I need to delete. For example, these ones will not be used by the system. And I'm not going to use this one either. Are we good? Again, these are 6x6 timber families. We load them last class, and we place them automatically at the intersection of every grid. All right. Let's switch to level 2. And now I'm going to show you how to create a system of beams. And I'm going to do one, and I'm going to show you how to do it. Maybe I'll show you how to do it in 3D is better. So a system of beams, it's a boundary of a set of beams that you create using a pre-selected set of boundaries. Before I talk about that, let's talk simply about beams. So on the structural tab, you're going to find a command called beam. And in a beam, right now I don't have wood beams. I only have a steel beam W12 by 26. But just to understand the concept, a beam is usually associated with the level in which we place them. But you can create it in 3D if you enable this thing, the 3D snapping. Now, you also need to make sure that you place it in the appropriate level. So these are beams that are placed along or right underneath level 3. So I'm going to switch this to level 3, because if you're a structural engineer and you want to schedule your beams, they will be scheduled by the level that is supporting. You should also select what kind of usage that is. This could be just girder. And then you can enable the 3D snapping. And 3D snapping will allow you to snap to the end of columns. So this is very important, the 3D snapping. I'm just gonna create one segment. So you snap from the endpoint of this beam, this column, to the endpoint of that column, and that creates a beam. Now, I'm gonna undo this because I don't need a steel beams here. What I need is actually wood elements. So let's load some wood beams using the library of components. To load components, you go to the Insert tab and then Load Family. And in the English Imperial Library, scroll down to the Structural Framing. That's the category of the wood beams. And in the Structural Framing, open the wood folder. And we have dimensional lumber, we have glulam beams, we have laminated plywood web joists, timber, open web joists, TJL and TJS. And let's see, I think I like the yeah, let's load the TJL wood open web joists. And this is remember what this is called? A type selector. What that means is that this family has a text file sitting right next to it that has all the values for all the different types. And so I'm going to select 18 inches. And you can just click it or double click it and then hit OK. So that beam is loaded into the family browser. If you scroll down and to the structural beam systems or the structural framing, you're going to find that 18-inch TJL type available for our use. All right, let's create now a beam, a simple beam. You go to structural tab, beam, and it's hosted on level 3. It's 3D snapping, and you can just go from the endpoint of this to the endpoint of that, and that is my wood beam. Now, these wood beams, if you select it, notice how it has these temporary values appear at the end of each grip. And these temporary values, it's a way for us to manipulate the beam height. For example, if I increase this to 1 feet, notice how this starts creating sloping beams. And if you assign it to 0, then it's gonna return it back to the original one. So you can place beams one by one, and I don't know how often you put beams, but typically architects don't do that. Sometimes we do it as a placeholder while a schematic design is worked out by this engineer. But let me show you a quick tip. I'm going to delete that, and I'm going to switch to level 3 floor plan. Floor plan level 3. Do not open the ceiling plan. Sometimes we open the incorrect one. And obviously here in level 3, I'm going to create beams. But now, instead of placing them one by one, I'm going to create a system of beams on grids, which is an option that's called here under the multiple tab. And what this is going to do is going to identify all the grids, and then it's going to span a segment of a beam between all the grid intersections. If you only want the beams to run in one direction, then only select the grids in that direction. So let's see what's next. So make sure they are placed on level 3, that the structural usage is the girder. Then you hit on grids. This enable a selection mode. Select all the grids in the project for this level. From the lower right to the upper left, and then hit the green checkbox. And let's see what happened in 3D. There it goes. Now I have grids. I have a beam for every grid intersection, and I didn't have to do it one by one. And again, if you just need the girders to run in one direction, just do it in one direction. I'm going to do it again. Beam, and then on grids. But instead of selecting all the grids, I'm just going to select them in one direction. Then you hit the finish, and then they are not visible in this view, but they will be visible here. The reason they are not visible there is because these are placed from level 3 down, and there's no visibility range under level 3. Okay, so let's stick with this version. Again, I'm going to do it again. If you want to undo and do it with me, go to level 3, hit beams, level 3 in the placement level, select girders as the structural usage, and select the option on grids. And let's just select the horizontal one. Don't select the grids running north-south, only the east-west. And I'm doing a crossing selection because everything that crosses this selection will be part of that. And then hit the green checkbox. And then in 3D, you should have all these grids visible. Ignore that warning. All right, so in the bay between the beams, I'm going to create a system of beams. And for that, I need to load dimensional lumber. And dimensional lumber, there's a family for the vertical framing in the form of columns, and there is a version of them in the horizontal one. So let's load that family. So you go to the Insert tab, and then hit Load Family. And then what I want is dimensional lumber. And actually, if you do a lot of residential and you use a lot of wood, dimensional lumber, it's a type catalog, and it's going to come with a lot of different sizes. So then you hit Open. And these are all your 2x, 3x, 4x available to you. This is the size of the profiles. And you can select multiple at a time. So I'm going to select a 2x6. I'm also going to select a 3x8. And you have to click Control. If you click Shift, it's going to select multiple things at a time. Yeah, and let's do the 2x4s. 2x4, 2x6, and 3x8. Then hit OK. And And now we're ready to create a system of beams. And a system of beam is something you're going to use if you, for example, you want to create a trellis, or you want to create a model existing conditions for the underside of a floor or the underside of a roof. All those are options available to you. Now, I need to take into consideration the thickness of the slab. So on top of this, there's going to be slab, and all these beams, the top of the beam, if I switch to a left elevation, the top of this, the other elevation, at the top of these beams is exactly level 3. And so what we need to do is to lower the beams, offset them a negative distance so that they are aligned to the underside of the floor. And so this floor is going to have I don't know, two plywood layers. So that's about, let's say 1 inch. Let's do an inch and a half. And so to let's switch this. To move all the beams exactly the same distance, select all the beams of the same type. So the fastest way to do that is you select one instance in the project, then right click, and then you hit select all instances in the project. And that's going to select all the beams of the same type. So I have a total of 16 beams selected. You can see that in the filter in the lower right side. And then these are the instance properties of the beams. And one of the properties is the Z offset value. It's exactly the same as, similar to the offsets from the columns. And what I'm going to do, I'm going to reduce this offset value by, I say 1.5 inch, right? So minus 1.5 inch. Again, this is selecting all the columns, and then now all these beams were moved 1.5 inches below the columns. All right, and now our system of beams are going to be joists. The joists are going to run north-south, so they're going to be placed in this direction, and they are going to be spaced at every, let's say, every 18 inches apart. So every 18 inches, you're going to have a joist. And so we're going to do this, rather than do this one by one. You can do this one by one, don't get me wrong, but this is placing a joist at a time is going to take a lot of time. And so system of beams allow us to automate this using parametric properties, including the spacing between the elements, the maximum number of elements, and the instance type. So let's see, the easy, we can do it in 3D. You can also do it in a floor plan. Let's do it in 3D. Yeah, let's do it in 3D. And then the next one, I'm going to do it in a floor plan. So to start a system of beams, go to the structural tab and select the beam system. If you do not have the structural tab, you need to load them. Remember the first class in the options. So you go to the beam systems, and this takes you to sketch mode. And that's a clue that this is a system family. And in sketch mode, we are going to draft the boundary of this beam system. So I'm going to use the 2-point lines and just snap it. I'm going to snap it from the center of the column to the center of the column. And you're going to see the center because it's, or the end point of the beam. And I'm going to select this opposite end. So I'm doing a big rectangle, center of the column, and then close the boundaries, and then escape. 4 sketch lines, snapping to the center of the column or the end of the beams. And notice this sketch line has a double line. And these indicate the beam direction. So right now, my system of beams are going to run in this direction because that's the direction of this double line. But I can swap the beam direction just by selecting the beam direction tool and then selecting one of these boundaries. Now the beams are going to run now east-west. But what I actually want them is for these joists to run north-south. All right, where the magic happens, it's right here where it says properties. Because these are the parametric patterns of the elements. And so these elements are distributed on top of our work plane using different rules. And the rules are fixed distance. This is how much distance is between the center of an element to the center of another element. And if you choose a fixed distance, there's going to be some residual. The residual could be placed at the end of the system or at the beginning of the system, or you can equally center them. For example, if I say system here every 1.5 feet or 1 foot 6 inches. Justification, it's where the residual distance is going to be placed. If you choose center, then the residual distances are going to be left at the end of the system. If you choose the beginning, then it's at the beginning of the system and is the end of the system. And the direction line is in the direction of this. I don't want a fixed distance as a rule. What I want is a maximum spacing. And so what this is going to do is calculate the distance from one end to the other and equally divide it up to that value. So it will be a maximum spacing of 1 foot 8, 1 foot 6. And notice how the justification disappeared because these are going to be completely equally distributed. And then the last item is to check the beam type. This is the type of joist I'm going to use. I'm going to use a 2x6. And I'm not a structural engineer and I'm not pretending to know how to build this thing, but I'm going to assume that a 2x6 is okay. You guys have more experience than I do. I've been just teaching tools all my life. All right, so 2x6, maximum spacing 1 foot 6. Direction, the direction is in this north-south, and hit the green checkbox. And now I have a system of beams spanning from one end to the other. Now, if you zoom closely, I also need to allow the joist not to interfere with the floor. So I'm going to offset this system by minus 1.5 inches. So it will be minus 1.5 inches. Apply. And now they are at the same place. Okay, we built this system of beams in a 3D view. I'm going to do it now in a floor plan. And the best way to do this is if I open level 3. I can actually level 3. Now notice that I don't see anything between level 2 and level 3. And I suspect that this is because the view needs to be switched to fine. And also the view needs to display an underlay. And the underlay, you can say display everything on level 2. And now you see all the beams below. Again, what I did is switch the detail level to fine in the view controls. This will allow you to display the beam in its full geometry. And then switch the underlay to level 2 to level 3, looking down. And your beam system appears grayed out because it's below level 3. But now I have some references that will allow me to create it easily. So I'm going to create 3 more. I'm going to do this with you, and then I'm going to give you 5 minutes for you to create the other base. Okay, so we go a structure tab, the structure panel, and then select the beam system. Keep the same properties. It's going to be a 2x6, maximum spacing of 1'6". The same properties are visible here. And just draw the sketch lines. Sketch beam system, and I'm going to start from the center of a column 2, the center of a column 3, and go around. Just select the center of every column. The direction needs to be north-south. And the elevation from level, it's minus 1.5 inches. Dimensional lumber, it's 2x6. And then you hit the green checkbox. And there it goes. It's now created the second bay. Now, on your own, create the bay between 3 and 4, and 4 and 5. Let's have 3-4 minutes to do this. And structure, beam system, and just go from grid line to grid line. Or you use the sketch method. Remember to use the sketch method. So use a lot the mouse to zoom in and zoom out, zoom in, zoom out. Especially when the buildings started getting big, and the beam system takes a big tributary area. Elevation level, remember this is 1.5 inches below the work plane. And now I'm going to do the last one. Okay. So your system should look like this, something like this. Now, eventually, we're going to have elevators, an elevator shaft. And an elevator shaft should be able to, like, in fact, I think we should decide that now, where the elevator shaft is going to be. Because in order for the elevators be clear of joists, then we need to define the opening inside the sketch line. So let's switch to a floor plan here. And just to verify what I'm saying is that we added the boundary of these sketch lines, and then you create an opening. And this is a rectangle inside the beam system. So this is going to become a void. And when I do that, then notice now that my beam system are stopped. And then you can frame it again with additional beams if needed, or with additional elements. In this case, you could add a beam. Well, we need to decide the final location. So that's not my final location of the elevators. So let's decide where the elevators are going to be. So I'm going to switch to level 2. And there are going to be several places for multi-story elements. We're going to have an elevator and we could have, I'm going to sketch it quickly. We can have like half of this module is going to be my place for the elevators. And then half the module of the lower side is going to be my place for the stairs. So these are stairs and these are elevators. And to make room for the elevators and the stairs, I need to edit my sketches of the beam systems and make sure that I allocate the appropriate space. And so let's do that. I'm going to switch now to level 3. I am able to see where these things are. And I'm going to start with this beam system, intermediate here. I may need to enable the selection of elements in the background. So that is this button, which enables me to select elements in the underlay. Or you can go to here where it says select and select underlay elements. It's the same thing. And so I'm going to select this guy here. And I'm going to edit the boundary. And I'm going to create lines that are going to align with the grid. And about 14 feet south, that's going to be spanning all the way to grid D. That is the space for the opening for the elevators. And then these sketch lines, do you think it's going to work if I click the checkbox? That's that, right? No, Revit get angry. And remember the 2 rules of sketch mode. Lines need to be continuous and they cannot overlap. So I'm going to split this sketch line into using the split command. The split command is right here. Is that, and that is the split. And the split allow me to split a geometry in 2 parts. You can do this with balls. You can do this with with handrails. You can also do this with sketch lines. I'm going to split this sketch line into portions, and then I'm going to use the trim to corner to clean these conditions. And I also, and remember the distance of this is 14 feet because I'm going to do the same opening in the bottom, in the other side. All right, so I click the green checkbox, and when I switch to a 3D view, what happened? This didn't work. Edit boundary. Go to. Hey, I got it here. So why is it not there? Do I have two of them? Let's see. This is on level 3. I'm not sure what's happening here. I'm not sure what's happening here, but this is not cutting at all. Let's see, edit boundary here. This is weird. I'm gonna try. I don't know if you guys seeing the same as I do. No, like when you create the opening, it doesn't do it. It didn't do it, but I'm gonna try to do it in 3D here. Edit boundary, and then I do a rectangle from this corner to 14 feet, I think we say. And then I'm going to delete this piece, split it, and clean the corners, and hit the green checkbox. It's not doing it. It's not doing it, and I don't know why.
It's not because you're extending the joist when you do the shape into it, so you don't have any more a boundary on that opening, so the joist will extend, right?
Yeah, but check this out. If oh, you know what happened? I exploded my system. That's what's happening. Right? Yeah, I exploded my system. No, wait, I'm gonna do. I'm gonna edit the boundary and leave it the way it was before. And I think what you're saying is that Revit is attempting to.
Yeah, once you cut it, yeah, that is. So the joists are content on that footprint, they're saying. But when you cut the footprint, so you open it and then the joists extend.
Yeah, but you see, when I do this, it works. It doesn't work when it's adjacent to the boundary. So I guess what I have to do is let's see, just leave a tiny bit in the back. It's not correct. Like this shouldn't work. This should work fine. Delete. I'm gonna. split this here and try to do it again. If this doesn't work, let me sit on this and find a solution for you tomorrow, next Tuesday. Okay, clearly this is not working the way I want it, so I'm gonna undo and leave it the way it was. Let's take care of the opening later.
Okay.
Okay, so now the last thing is to add the diaphragm. The diaphragm on top, it's 2 layers, it's 1.5 inches.
Mhm.
So what I'm gonna do is select the level below,
Mhm.
the one on level 2, copy to the clipboard, and then I'm gonna paste it on top, align it to a selected level. And I'm gonna select level 3. Again, copy to clipboard. You can do also Control-C and align it to level 3. This is the floor, but I need to change it.
Mhm.
I need to make it 1.5 inches, but now we know how to create new types based on an existing one. We edit the type property, that's step number 1. We duplicate it, that's step number 2. And I'm gonna call this a diaphragm. Did I spell it correct? And this is going to be 1.5 inches. We could give it a plywood material. Yeah, why not? Let's go to these 3 little dots, and that's going to open the material library. And in the material browser, you can just search for plywood. There is sheeting. Plywood sheeting, 1.5 inches. Click OK, click OK. And there you go. This is the plywood. It might be a little too off, it may be offset a little too much. So what I'm going to do is fix that in level 3. Like you see, it has this overhang, and that's not correct. Because then what's going to happen is the curtain wall is going to sit on top of these concrete floor and span multiple levels. But then the floor needs to be aligned with the edge of the column. And so I'm going to, the best way to do this is to switch to level 3, floor plan level 3. Select the floor and edit the boundary. I can do all of that very quickly using an offset. And this is the first time we're going to use the offset command. The offset, it's in the modify tab. This icon that looks like 2 bubbles here. And we need to interrogate the distance of the offset. And so that distance is going to be, you can measure elements using this measure tool. A measure, it's you can call it a transparent command, because you can use it in the middle of any command. If you need to like get an idea of a measurement in the middle of a command, you can invoke the measure tool, and this is 1 9.25. And in fact, this is the total length here. You can drag it from the cell. You can right click and copy, and that way you don't have to type it. I know that is the offset distance. I need to offset this line by 1 foot 9 1/4. And I discover that distance using the measure tool, and I measure from the column to the edge of slab. And I highlight the distance, right click, copy. And now using the offset tool, I'm going to use an offset of minus, you can just type it, minus, and then paste. I don't want a copy. If I need a copy, the line is going to stay as it was. and then hit enter. Really? Doesn't do negative stuff. Enter. I don't like it. Okay, let's try it differently. I'm going to okay, select the floor, edit the boundary. Then I'm going to select all the lines. You just to select the chain of all the lines, you tap select, and I have a total of 8 lines selected in the selection. And I'm going to hit with those selected. Then I'm going to do an offset, and I'm going to do. You see the preview. Disable the copy, and do the preview towards the inset. Oh, but this is doing it one by one. Ugh. I guess I could do it one by one. And then after clicking that, all my offsets are clear. The distance is 1.914. Disable copy, otherwise you're going to be left with the original sketch line and you won't be able to finish. When you zoom in, the edges of the floor are aligned with the columns edges. And when you hit the green checkbox, switch to 3D, then it should be cleanly placed. The joist should be like right underneath it. All right. It's almost 7. We still have time to do the. Let's change these. Let's change these. Let's copy all the wood structure from level 2. And we were going to put it on level 3 and on level 4. And we don't have to do it again. All we need to do is copy and paste. And it's going to be right on top of each other. And so the easy way to select just the elements on level 2, between 2 and 3, is to switch to a 3D elevation. So a 3D elevation is different from a projection elevation. The projection elevations are available to you as north, south, east, west. These are projection views. But to switch to an elevation, you just select the left or the right of the project. And then do a crossing selection of everything intersecting the boundary between level 2 and level 3. There are going to be a lot of elements. What the heck is this? There's going to be, I have 43 elements selected. There are things I don't want to copy. For example, I want to exclude the levels. But in this selection, you filter the objects. And the things you're going to copy are the floors. You're not going to copy the levels, but you want to copy the rest of it. The beam systems, the columns, the girders. There's a total of 42 elements. And then copy to the clipboard. And paste a line to select the levels. And I'm going to pick level 3 and 4. Then hit OK. And my structure for the upper levels should be exactly the same as the one from level 2 to level 3. You know what? I think it didn't like that. It didn't like that. I think there are elements that are redundant. So let me undo this. Yeah, and let's do this way instead. I'm going to switch to the right elevation because I have the joists there visible. And so what I'm going to do is just select the columns. Just select the columns. Don't select the beams or the floor. And you can do it using a crossing selection. Or you can just do select one column, right click, select all instances in the project, and it's going to select all the wood columns. So you can copy the columns to the clipboard and paste them to level 2, no, to level 3 and 4. Why doesn't it like it? Let's do it again. Let's do a window selection of all the columns and then copy to the clipboard and paste them to level level 4 and the roof. That's what it was. That doesn't make sense because this extend from level 4 to level. So I guess it's copying it based on the top level, not from the bottom level. All right, well, that worked. So what we need to choose is level 4 and the roof level. I'm going to rename level 6. I'm going to call this parapet. And now let's do the same for the floor and the beams. So you select everything using a window selection. I'm using a window selection instead of a crossing selection because if I do the crossing selection, it's going to select everything. The window selection starts from left to right. So I select all the beams and floors, copy to the clipboard, and then paste on level 4 and the roof. Level 4 and the roof. And the system of beams will be carried. And when I switch to a 3D view, which I am already, I should have my little building structure finalized. Okay, so with this, I think I'll wrap the structural discussions. I mean, there are other things that I don't typically teach to architects, like how to create isolated foundations or wall foundations or steel connections. We just don't have time, and we usually don't do that, or the reinforcement portion of Revit. And typically, if we model the structural elements, because there are existing conditions that we need to be cognizant about, or because we are doing a placeholder while the structural engineer is designing. Sometimes, and when it comes to the floor, and especially in projects of medium size, architect is usually the owner of the floor during schematic design and probably 50% design development. And then after 50% DD, the boundaries needs to be aligned and finalized, and engineer will pick it up, give it the appropriate thickness, the appropriate materials, the proper reinforcement. And what we typically do, we link the structural elements and we switch off our floors, but we enable just the structural floors to be visible. And the same is true with the columns. We start a project like this and we have placeholder columns. You tender these columns only to a schematic design. You can put it in a single work set. And then when there's a swap of design or swap of ownership, you only display the structural link. And so I'm going to I'm going to assume this is a structural model. I'm going to save it. And then I think next class, I'm going to start a new building from scratch. And I'm going to assume that this is a structural model that was built by a structural engineer. And we're going to link the structural model into the brand new architectural model. And then all the interior walls, all the interior, all the exterior envelope are going to be modeled in a brand new model, which is the architectural one. And so let me get started with the discussion of the curtain walls, because next class is going to be everything about curtain walls. And so I'm going to show a few slides and then we're going to stop there.
Caesar, did we get your secret sauce slide deck?
Yes, I think it's already there. If you go to Google Drive, should have it there. Drive.
Okay, I can look later.
If you go to Rack Summer 2021 and go to documentation, no, not documentation. I had it put there. Oh, here's RF compile. It's a PDF.
Okay, it's beautiful.
Yeah. Okay, so a curtain wall, it's a system family that is made of, it's a special system family because as a whole, as an assemble, it meets the criteria of being a wall. So a wall is a system family, but it's built of a lot of components, and these components can be loaded as an external file. And so curtain walls have curtain grids. A grid is a subdivision of a panel into multiple surfaces. We have mullion. A mullion is a two-dimensional profile extruded along the path of a curtain wall, and it defines the shape and the material of a curtain mullion. And then curtain panels, which are families that you can create with different surface properties. And so in a nutshell, to create a custom curtain wall, you start by creating a gigantic piece of glazing. This piece of glazing is undivided. It's start from one level, ends to a different level. It could be multi-story. And by default, there are boundaries associated with the curtain wall. Just for reference, this is called the bottom. The bottom one is called horizontal side one, and this is called horizontal 2. And then the verticals are called, the first one is called vertical 1, and the other is vertical 2. And the order of vertical 1 and vertical 2 is the order in the creation of a wall. So if a wall is created using 2 points. And so the first point is the vertical 1, the second one is vertical 2. border 1 and border 2. That's how it's called. Horizontal border 1, horizontal border 2, vertical border 1, vertical border 2. Then this gigantic piece of glazing, it's subdivided in panels using grids. And the grids can span from one border to another border, both in the horizontal and vertical. Or you can also create segments of a panel spanning from one panel end to another panel end. This is the part that takes the most when you're doing this manually, because you have to manually adjust what is the different size, what is the rhythm that you want to create using it, and what's the design intent. Then after we place the grids in the appropriate location, we create mullions. The mullions, it's a profile, two-dimensional profile of a certain size, width, depth, and it's extruded along the length of the grid. And you can have different mullion profiles for different purposes. For example, you can have the top mullion have a structural purpose, or the vertical ones have a different function from the interior ones, because one is going to attach the is going to have attachment mechanisms to the structure adjacent. And finally, we have panels, and a panel is it's an assemble. You can use a wall as a panel. The doors in Revit, curtain walls, is a special panel family. So you're not going to be able to place the regular door inside a curtain wall. You actually need to load a panel that is called curtain wall doors, and only that type of family will work as a door inside a curtain wall system. So this is the typical process of creating a manual method of creating curtain walls. So next class, we're going to go over the process of doing this. Again, save this model. And if you want to do this, just do it now. Just save as and call it my first building underscore structure. And next class as well, I'm going to show you the process of copy monitoring, which is a way to recreate levels and grids based on another model. So rather than creating all these levels again in a brand new project, we're just going to inherit them automatically from a source file. In this case, the structural model. And then we're going to build all the interior layouts of this building using architectural elements. So again, save this file. If you fall behind, feel free to check the recording. I'm going to stop the recording now.